We are starting chapter 8. We are going to classify polygons, but we are going to use other characteristics other than just their sides. We've already covered that, reviewed that today. Our first keyword or vocab word would be a convex polygon. A convex polygon is one in which is convex if no line that contains a side of the polygon passes through the interior of the polygon. No line that contains a side of the polygon passes through the interior of the polygon. What they mean by that is that if we take this polygon that they drew first, we take the sides of it and draw lines through them. You can make them solid, you can make them dotted, whatever you want. But if we trace lines over the top of those sides, none of those lines ever go into the inside part of that shape. So that's what the second diagram shows. They extended all of those lines and it never went into the inside of that shape. We can still just outline it. Some of those lines might cross each other at some point, and that's fine, but they didn't go into the middle of the polygon. Next, we have a concave polygon, which quite simply is a polygon that is not convex. It caves in on itself. So that means when we extend at least one side and it crosses into the center or the middle, we call it concave. We think of these as having caves, meaning it goes in on itself. See out in these corners? It caves in on itself. Or if we extend that line, they just did one of them, but you could extend several of these sides to cave in or go into the middle of the polygon. Now you might notice that on this shape, there are some sides that we can extend with it not cutting into the middle. Okay, some of them won't go into the middle, but if even one line crosses into the middle when we extend it, then it's still considered concave. Much like the words themselves suggest, an equilateral polygon has all sides congruent. Equal, lateral means side. All sides are the same. For equiangular, very similar, all of the interior angles are congruent. It's important that we're talking about the interior angles, not the outside ones. A regular polygon is both equiangular and equilateral at the same time. So those blanks below it be all sides congruent and all interior angles congruent. That's what it means to be equilateral and equiangular. All sides congruent and all interior angles congruent. On these first 4 examples, you need to get those diagrams copied down. They do not have to be perfect, but they should be similar to what you see on the board. And we are going to have to decide if they are going to be convex or concave. When we're deciding if it's going to be convex or concave, if you're not sure when you look at it, I would start tracing along the sides and seeing if when you trace it, you end up drawing inside the shape. Now on this first one, I drew over all of the lines. Did I ever cross into the middle? No. So which was this one going to be? Convex. If I never cross into the middle, it's convex. So what do we think about the second one? Concave. Even though a lot of these sides don't cross into the middle, As soon as I have one that does, I can stop. This one here crossed into the middle when I traced over it. So that means it has to be concave. It caves in on itself on this side. What do we think about the third one? Concave again. If you see where it cuts in, you can go ahead and trace over that right away. It cuts into itself over on the left side. So that is concave. What about 4? Where does it cut into itself? Where at, Kian? Yeah. Like here? Yes, these would cut into it. So that makes number 4 concave. On the next set, we have to decide if these polygons are regular. In order for it to be regular, it has to be 2 other things. What 2 things does it have to be? What has to be congruent? Sides and angles. So ask yourself, is it equilateral? If the answer is yes, ask, is it equiangular? If the answer is yes again, then it's regular. But if you answer no to either of those questions, then it is not going to be regular. All of the interior angles are congruent. On number 5, is it equilateral?
Yes.
Yes, all the sides are marked as being congruent. Is it equiangular? Yes, again, all of the angles inside of it are marked as being congruent. So this one would be regular. If you answer yes to both, it's regular. If it's not yes on both of them, it can't be regular.
So do you write it if it's not? Do you write what it is if it's not regular?
You just write not regular. If this is the question, regular or not, we could put not regular. So on number 6, is it equilateral?
Yeah.
Are all 4 sides congruent to each other?
No.
The answer is no. Some of you are saying why. On number 6, some of you had the right idea, and it sounds like some of you did not. This is not equilateral. Just because we have pairs of congruent sides does not mean all the sides are congruent. For it to be equilateral, all of the sides have to be exactly the same as each other. That is not the case if some of the sides have 1 tick mark and some of the sides have 2. So this is not equilateral. So do we even care about whether or not it's equiangular?
No.
Not really. If our question is regular or not regular and we already said no to one of the conditions, we can go ahead and give our answer. It is not regular. If you need to know why, it's because it was not equilateral. Sometimes you might be asked to explain. This one doesn't specifically say it, but in case you're ever asked to explain, that would be our reason. It was not equilateral. That's how we know it's not regular. On number 7, is it equilateral? Yeah, it's equilateral. How do we know?
All the sides are the same.
All the sides are marked with 1 tick mark. So all the sides are the same. So it is equilateral. Is it equiangular?
No.
No, it's not. First of all, they're not marked. Also, we can see that here we have a very large interior angle to get from that side to the other one. And up in this corner, we have a very small angle. But either way, they were not marked. So this is not regular. Just because it met one condition doesn't mean it meets both. If we had been asked for a reason, we would say that it is not equiangular. All right, on the next ones, we are asked to find the value of x. We are told that these polygons are regular. So what do we know about them? What's all equal? The sides and the angles. So if we are told that they're regular, we know a lot about them from the very beginning. If we know that all of these sides have to be the same, how do you think I'm going to solve for x? Jaden? Set two sides equal to each other. So we have a side that was labeled 6x plus 1. And we have a side that was labeled 25. If it's equilateral, those sides have to be equal to each other. How am I going to solve it, Martez? Subtract 1 and then do what? Divide by 6. What do I get for x? X equals 4. Questions about number 8? On number 9, what equation am I going to set up? Okay, we can set it up as 15 equals x minus 3. Again, they said it was regular. All the sides have to be the same. Add 3 to both sides. What do we get for x? 18. This is really it. Remember, the first lesson of every chapter is usually very easy. Are we ready to continue? All right, we're still told that these are regular. So who can tell me what equation I should set up for number 10? 5x minus 4 equals 21. How am I going to solve for x? Add 4. 5x equals 25. Last thing. Divide by 5 and x equals 5. Now on number 11, it's set up differently. We are not given sides. What are we given instead? Angles. But it's still regular. So what do we know about the angles? They're congruent. So what equation can I set up? 11x minus 2 equals 108. How am I going to solve it? Do what? Add 2. 11x equals 110. And then? Divide by 11. What do we get for x? 10.